Hey, hello, and welcome to the show. It is me, John Park. It is time for John Park's Workshop. It's actually an hour after time for John Park's Workshop. Sorry, due to circumstances, we had to push an hour today. I hope it is not too late for some of you. Maybe it's super early for others of you in weird parts of the world. I shouldn't call them weird, in different parts of the world. Hello to our peoples in the chats. We've got Johnny Bergdahl, Blitz City DIY, Paul Cutler. Hello, hello. Dave Odessa. Here's our Discord chat, by the way. If you're wondering where the chats are, that's a good one to check out if you're over on Facebook or LinkedIn or Twitch or, I don't know, Twitter. Do we still do that? And you're wondering, why is no one here? It's because we're over in the Discord chat. That's kind of our unified chat. You can head over to adafruit.it/Discord and look for that live broadcast chat channel that you see right there on the side. It's right there. Hello, Todd Bott. Hey, C. Grover. Nice to see you all. So, yeah, the stuff I'm working on today, we've got, what do we've got? We've got a coupon code for you so you can buy some stuff in the store. That's what helped keep the lights on at Unified Adafruit Industries all over, distributed. I've got a recap of the product pick of the week from the Tuesday show. I've got a CircuitPython Parsec for you. I have a little, I'll do a little update on the PlayStation controller from last week. I'm working on the guide for that. I'm actually going to have to run and grab that to show you the thing I want to show you, I think. Lots of stuff going on for the new project that I'm going to be starting today, which is the joystick X-Arcade conversion. It is, in this case, the Tankstick, but this will work for pretty much any arcade cabinet style or joystick style conversion that you want to do to use it in a modern system with USB. I've shown this one before when I got the device. You might see a little piece of it poking up over there, piece of a giant joystick. Is it that thing right there? Ooh, look at that. That's what we'll be working with. And that should cover it. So let's see. Let's start off with a coupon code. This is today's coupon code, appropriately enough. Joystick. What are the odds? That will get you 10% off in the store. Just go buy your stuff, and on the way out, look for the coupon code field. Type in joystick. I have no idea if it's case sensitive, but I'd do it in all caps just to be sure. And that will get you the discount today. If you want to take a look, here is the Adafruit store right here. Under products, new products, view all. You can see some of the cool new stuff. These are not in the store yet, these cool cameras that are coming. But here's some flex cable for the NVMe base for the Raspberry Pi 5 if you want to use a fast hard drive with it. We've got this little cute Electfreak Smart CuteBot Pro. We have a bunch of new IR stuff. We've got breakout boards for analog switches. There's actually a new guide that Liz put out for these analog switches that you can go check out. Looking forward to using those and seeing what projects Liz comes up with for those. And more and more. So if you want to get some of that cool stuff and get yourself a little discount, joystick is the coupon code, and that's going to be good today until midnight tonight, East Coast time. I think that's how that works. Next up, let's. I'm gonna see if I can show you the recap of my product pick of the week, and during that, run to my little studio office and grab the PlayStation controller. So I'm going to disappear for a second, but this is what I'm talking about right here. I've got the product pick of the week show on Tuesdays, on which we have one or two or more products. We had 2 new ones this week. I like to do a little demo with them and give you a big, deep discount just during the show. There's no coupon codes on that one. This week it was these cool programmers, so check it out. The UPDI programmer and the high voltage UPDI programmer. USB serial programmers, which you can use with your ATtiny chips. 3-pin JST-SH cable that it comes with. That is going into the power on my little ATtiny 1616. I've got ground, and then I have the data pin going to the UPDI pin. Got a bunch of these little LED noodles, little nudes plugged into there as well. When I plug in the UPDI friend there, and now if you look in my Arduino session, when I hit upload using programmer, you're going to see it is going to very quickly make the connection, upload, send the code, and boom, now I have all of these 4 pins doing PWM stuff. Unplug the UPDI friend. Now I can battery power this. UPDI friend doesn't need to be plugged in anymore. UPDI friend and UPDI high voltage friend for programming your ATtiny chips. Yes, indeed it is. And I even made it out and back with this thing, so we'll talk about that in a little bit. Let me know if you put together any cool stuff on your ATtinys using that. That thing is super slick, very cool. All right, we can start to settle down now. Looks like things are up and running. So, next up, I'm just setting up a little demo here for our CircuitPython Parsec. And I'm also going to open up a little image I want to show of a pinout diagram. So let me try to not, there we go. I'm going to try to not short out the project. Phew. Right, so let's grab these, but I'm also going to add an image file. Give me 1 second. Where are you? I think well, the question is, where did I put this? You know what? I'll just go to the web page instead. Let's add a we'll add this Chrome capture on top and Adafruit. Let's go to Feather RP 2040. And I'll go to the Learn Guide for it. And pinout page, pinout diagram, original, full size. There we go. Okay. So yeah, we'll start with it like this. Here we go. For the CircuitPython Parsec today, I want to talk about pinout diagrams and names of pins. So what I have here, you can see I've got a Feather RP 2040 that's busily blinking away. Turn on a little light there, you can see it a little better. And off to the side here, you can see this is the pinout diagram from the Learn Guide for this board. I'll zoom in even a little bit more, and What you can see here is on the left side of the board here, we have pins like A0, A1, A2, A3, and so on. So those are the board names, and they are what's silk screened onto the board. When we're using CircuitPython, very often we will talk to the pins using those names. However, when you look at this pinout diagram, one of the really important things that you can also see next to these CircuitPython names is the actual chip names. That's the column in yellow here, and it exists on both sides. So pins like A0, A1, A2, A3 are actually, for the chip, GPIO 26, 27, 28, 29. You can see sometimes these aren't in an order, sometimes they're mixed around, sometimes their names have nothing to do with the CircuitPython name. You can, however, use either of those names in CircuitPython. So if you look at my code here right now, I am going to go ahead and uncomment this section right here and save that. And I'm going to go ahead and also go to that board. 1 second. Okay. So what you can see here is that I am calling this variable LED pin by the name digital IO, digital in out, board A3. And then I have a little LED and a resistor plugged into ground and board A3. If I want to use the microcontroller name instead, that is what we saw on this chart here. A3 uses GPIO 29. So I'm going to go ahead in my code and say LED pin equals digital IO, digital in out microcontroller dot pin dot GPIO 29. I'll hit save, and the same thing is happening. So really, CircuitPython doesn't care. It's using the same pin here, just being called by two different names. Now, one interesting thing you can do is if you go into the board itself in the REPL and import board, you can ask for the names of the pins on the board simply by saying dir board. And there you can see A0, 1, 2, 3, boot, button, D1, D10, all of these names that are familiar from the silk screen. If I import microcontroller, I can now do a similar thing. We're going to say dir microcontroller.pin, and now we're getting a list of the GPIO pin names that are the same as the chip names. Now, one interesting thing about this is that these are very often the pin numbers that are used in Arduino. So if you're moving back and forth between Arduino and CircuitPython, sometimes you might find it helpful or useful to know the name of the chip pin rather than worrying about the silkscreen pin, because it's going to be very likely the same in Arduino as in CircuitPython if you call it by this name. And so that is how you can use microcontroller pin names as well as board names in CircuitPython. And that's your CircuitPython Parsec. Now, as one other little bonus thing on here, I'll say if you're new to these pin diagrams, they can be a bit daunting because look at all this stuff on here. Really, those pin numbers or names that are seen in gray are the ones you'll worry about the most in CircuitPython. That's what you'll call those pins. And then these yellow ones are those chip names, usually similar to what Arduino will have them defined as. The rest of these aren't really names that you're going to call directly in your code. They're a bit more informational. So for things like your SPI bus or your I2C bus or your UART bus or PWM pins, you'll have little channels or groups of these that sometimes you'll need to use in pairs or use in sections so that you don't have conflicts. So for example, you can call PWM-A and PWM-B pins, and those are going to be listed here under the channel PWM-5A and B, 6A and B, 4A and B. When you want to call two of those, you'll call a pair, and you will use the chip name or the GPIO, or rather the silkscreen name, but this little information over here on the side just lets you know, hey, those share something. Those are pins that you might need to use together so you don't run into other conflicts. So those two inner ones are the ones that you'll actually look at for calling the pins directly. But I thought that would be useful. You can also see things. Here's an interesting case. Back of the feather here, we have a stemma QT port. Well, sometimes you want to sneakily use that instead of for I2C, which is sort of its intended use, just as yet another GPIO pin. Let's say you're running out of GPIO pins. It'll happen on some smaller boards sometimes, and you just want to eke out one or two extras. Well, yeah, these are considered to be the I2C under stemma QT, but they're also chip pins GPIO 3 and GPIO 2. So if you're in Arduino, you might call them that way. If you're in CircuitPython, you could still call them SCL, SDA, but you can get specific here and use GPIO 2 and GPIO 3 instead. So those are some interesting things, I think, from our little board diagrams that you'll find for all the boards. Okay, so moving on, I want to go to just this downshooter cam for a second, and I'll get this out of the way. And I'll actually pull that power from the feather. And I talked about this last night on the show and tell. I actually can't remember if I actually plugged the thing in. I talked about using this little USB-C connector just to get power and ground to my battery charger that's on the PlayStation controller. So let me refocus here a little bit. You can see this is, if I press my start button here and open this up, you can see I'm connected to Bluetooth on my Itsy Bitsy. There is a charger under the battery. This is running under battery power right now. And that charger, since this is not an accessible port, I had to add a USB port up at the top here. This one here is really nice and small. I just have it essentially CA glued to the PCB. I also put some Kapton tape on there to keep it from shorting to the back of this in any weird case where this gets moved. And when that, I'll leave this open for a second, when that is plugged in, you'll see the charging board. That's the little Pro Trinket backpack charger there. You'll see that light up. And I actually have a tiny hole I drilled in this side of the controller, so when this is closed, you can see that that little red light in there. You're actually seeing it through the seam there. It's a little hard to get on camera, but that light will let you know that we're charging, and then I believe it goes either yellow or off. I think it just goes off when the battery is full, but if there is an LED, you'd see it. And then I do have a second hole drilled there so that we can see when this is connected to Bluetooth, which it just went to sleep. It's one of the features of this is that it goes to sleep after, I think I have it at 30 seconds right now. But when that little Bluetooth connection is made, then we'll see that, that through this little hole there as well. So I thought this was a good solution for this type of adding a little port. It is as small as it gets. You can have it protrude a bit so we don't bump into any of the case material with the USB-C cable you're using for charging. And the one test I need to do, and Lamore mentioned this last night, is I'm not sure if it has the proper settings to get a power delivery charger to send 5 volts, 500 milliamps. That is, I think, the default that a lot of those will do in the absence of any resistors that tell it what to do. So this one is just dead simple. I don't believe there's any resistors on there to tell it anything. It's just letting 5 volts through and should be half an amp. So that'll be good for charging up your little battery in there. And that code is now up and committed into the Learn guide repo. In fact, let me head on over there real quick. Show you that. So if you, I don't have the guide up yet. I'm working on the guide, but if we go to, oh, I'm not logged in, but that's okay. Adafruit. And I'll just click here. Should be a recent one, Learn System Guides. Recently PR'd. And if you search in here for PlayStation, PlayStation BLE, and I just updated this to add a timeout for checking for Wi-Fi. So one of the things you'll do with this code, if you want to be able to upload code to it without pulling it apart and plugging a USB cable in, you can use the over-the-air Wi-Fi feature that's possible on that ESP32. It will show up as ESP32.local if it's on your Wi-Fi network, and then you can upload code to it, which is really cool. Right here, you'll update your SSID and password for your local Wi-Fi. I had been doing this, and then at one point I realized I was not getting the controller connect. It's because my software, my code there, the Arduino Sketch, was hanging when I was not near that Wi-Fi. I had forgotten to add any sort of, it was just sitting waiting, so it was waiting forever for Wi-Fi to connect. So I added a little timeout. I think it just takes 3 seconds now. It'll check for that Wi-Fi connection. If it makes it, great. If it doesn't, it moves on, and you might need to go in and tinker with this or get closer to your access point. So anyway, that now is available if you want to go check that out or get a head start on it, and I'll be working on the guide over the next couple days so that you can make your own PlayStation controller that will connect up to your computer for some emulated games or whatever, or real games, not emulated. Okay, so next up, this is the new project. Was there something else I was going to show? I think that was it. So let's get on to the new project. The new project, I teased this a while ago when I first got this nutty controller in. You can see if I come over here, this thing is as big as it looks. It's ginormous. And this is a X-Arcade Tankstick. Oh, I just told Street Fighter to start again. I was hearing that music. I was like, what's going on? Let me get that to pause. Hey, there we go. So if you look over here, it's an old product. I got it for free from someone who was giving it away. You may still be able to buy one somewhere for 200 bucks, but if you check out eBay, seems like they're running closer to 100 or less. You got to count shipping in there. And really what I'm showing here would work pretty much for any type of arcade-style joystick. So if you want to build a fight stick that has one joystick and maybe 6-8 buttons, if you want to gut something and make your own, if you want to take something like one of these, this is the original Nintendo joystick. It's actually a pretty nice little joystick, has a heavy metal plate, has some good weight to it, a little 4-way joystick, a few buttons on there. The GP2040 firmware, which is something I've used before in a couple of projects. Robert Dale Smith has written a number of Learn guides on Adafruit for making gamepad controller joystick type of projects using a Pico RP2040 or a KB2040. Pretty much any of the RP2040 based boards have a build for them. And what it allows you to do is take all of the many arcade button connectors, and we'll open this up and take a look at it, hook them up to your Pico or your other RP2040, and then use this excellent firmware that's super low latency. People actually play fight game tournaments with this thing. It's not going to slow you down at all, especially me. I'm not that fast or great a fight game player. But it is a really great firmware and ecosystem for configuration. You can also do things like add NeoPixels to it if you want to have colored buttons lighting up. You can add a little OLED screen. There's other extensions or add-ons like that. So what I wanted to do first is just show you it in action a little bit, and then we'll pull it apart and show you how I'm wiring this thing up. And then we can take a look at the software. So let's go over here. And I want to show you what, let's see, let's do, yeah, I'm going to switch cameras actually. Get my camera switcher up and running. And you can see, as long as I don't get too bad a glare on there, I've got external monitors plugged in my laptop, and I'm running a OpenEMU emulator with Street Fighter 2 Turbo, I think it is on here. And I can't look at that screen because it's kind of broken, so let's try. Okay, so the real test is doing things like spinning kicks and Hadokens. So those are, you know, you've got, there we go. Nope. I'm backwards. Oh, I got killed. So to be able to pull that off with little thumb button things is really difficult. So any of your fight games, these are great for. Also stuff like Pac-Man. Let me, in fact, let me see. Do I have, let me see if I have, I think I have a Miss Pac-Man on here. Is it under NES? NES? No, I don't think I have it. What about an arcade? What's over there? Miss Pac-Man. Let's see if that runs. And so in this emulator, I'll have to do a controller setup. So the nice thing is we have sort of a couple of layers of pin setup. You can choose from different arcade joystick or controller standards like X input. Oh, it doesn't want to run that one, sorry. It'll show up as a Xbox 360 controller, which is a pretty common one for things to have drivers for. You can do, I think, PS3, PS4, Switch, and a couple other more obscure ones. Direct input, which is an older standard that will tend to work when others won't. And yeah, okay, I won't impress you, but with my Pac-Man skills. But I'll tell you, I tried playing some Miss Pac-Man with the PlayStation controller. Is terrible. You can't. You always get hung up on this. A real 4-way joystick works great. You can actually play stuff like Pac-Man. So I'll put this stuff away, and let's pull this guy apart. So I'm gonna, first of all, unplug it from USB. So what this originally had, this thing is old enough that it had a PS2, and not PlayStation 2, I mean like mouse keyboard PS2 jack, and a DB9 parallel port looking joystick port for your sound card kind of thing. These were plugged into the controller board that's on here. So I'm basically ditching the controller card on here. I've pulled this out so I just have a spot to put my own USB. And if you look here, let's switch cameras up. You can see there's actually some extra buttons on the back. There is a cable for pretty much just this trackpad. And I haven't tried this in a while. I think it shows up as a mouse, this trackball rather. So I'm not sure if you really be able to use that with this setup. I don't think the GP2040 has a provision for trackballs. Maybe that can be faked with one of the other encoder type of choices it has. But on the back here, there was a little hole and a sort of grommet for this discarded connector here. I've just put a little micro USB extender there, so I can plug a micro USB B in there, and I might switch that to USB-C, we'll see. This is unused by me, but it's a 4-way selector switch, so that could be pretty easily set up to have your system switch over to switch mode versus direct input versus X input versus PlayStation. I think you might be able to use that for that. And then this thing is just covered in buttons. So what I'm going to do is, let's flip it around like this. And I do have a couple of wooden boxes here I can set it on so that I can rest it on the bench here because the joysticks get in the way otherwise. And I can move this over to the side. I may have to noodle with the camera a bit so that I'm not in the way of the stuff you want to see. Oh, there it goes. Now it's resting on the joystick, so that's not what I want. Okay. So I've got, they're originally, this was, when I got it, it was in its original box, and the styrofoam had started to disintegrate and weld itself to this contact paper. So I may just strip this contact paper off. It's just MDF underneath. And cut some new vinyl or contact paper for that. I did add, there were rubber feet connected to these that have disintegrated, so I added 4 little temporary sticky bump-ons there. And I don't want to lose these, so I'm going to stick these screws onto a magnet. And so what I'm using for the microcontroller in this case is the Pico RP2040. And one of the reasons I was ready to revisit this project, I had sort of done a little prototype a while ago, but the reason I was ready to revisit it is that we now have Lamore made a Pi cowbell that has little screw terminal blocks on it for every GPIO pin, for every pin on the thing, which is perfect for this sort of thing because we have some wiring harnesses that we want to be able to connect to whichever pins we want. You probably want to do some experimentation with that and not just solder them down, but having them just kind of poking out of pin headers would probably lead to heartache pretty quickly. And so let me get a slightly bigger screwdriver. There's not an easy way to pick this out. This is screwed down, and then it's got such a tight fit with this probably CNC'd MDF that there's nowhere to get your fingers in it. There we go. Yeah, okay. So it's just a little MDF there that I'm gonna, like I said, probably replace this. Or I might try, I have some good 3M spray adhesive. I might try to put that out in the sun so it's soft, spray it, flatten it, iron it, put a weight on it, see if we can get it back in shape. So here's what we have. I think I'm going to move my camera other view just so that the stuff I want you to see, you can see like so. DJ Devon 3 says a nice mod would be maybe to put a molded lap shape for your thighs, so you can set this on your lap. That would be great. Yeah, this thing is not super lap comfortable. Okay, so I'm going to zoom in a bit here. And what you can see, this is the controller board that it comes with. And there are more modern ones. I think you could buy, one of the things that they have on their site, I think you can buy maybe for like $100 or something like that, a replacement for this original board that I believe would give it a USB out. And that you could be done with this, move on if you don't want to tinker and build it yourself. But I did. So rather than get their board, since you can see this is really Hello, hello. Those were the batteries I failed to check before the show. Sorry about that. Thank you for the warning. It was the receiver had lost battery. I think this one's still got 3 bars of battery. That's good. That's full. Sorry about that. Okay, so let's go back to that view over there. Okay, so what I was saying is on the, I don't know how far back it went, but this is the controller board that this comes with. You can get a replacement that's more modern. I think they're like $100 or $130 or something like that, but we're going to use the Pico and the little screw terminal breakout instead. And what I was saying is this is really nicely put together, all of the buttons, joystick buttons, etc., all the ground runs, they all terminate in these 5-pin JST XH, which we just happen to have in the Adafruit store, a JST XH kit. And so rather than me trying to mess around with this type of arcade wire, which we have, these are great, it'll plug right into each switch, a little spade terminal connector, and then we could trim these ends, strip them and put them into the terminal, but I wasn't really looking forward to that much wiring, and instead I realized, hey, since they've already got, for example, this is joystick 1, and I just figured this out by tracing it. This joystick 1 JST XH cable has ground, up, down, left, right. And that exists on another one here for the other joystick. Clumps of 4 buttons are arranged that way. They all have ground. That's why they're 5. They have ground and then 4 buttons. So what I was able to do is take our little kit here. And I can zoom in for a second so you can get a little closer. Take our kit here. That is the wiring harness from the arcade stick. This is, in our kit, a 5-pin XH of the other gender there, meant to solder down onto a board. But what you can do is take our little multicolor jumper wire kits that we have here. I put heat shrink tubing on so they wouldn't touch each other, but you can basically plug these in and it makes a nice solid connection in there. Click, click, click. If you're feeling more permanent about it, you could also hit that with some solder. But what I've made are these little adapters here, that you can see my heat shrink on there, that we can just plug their neat little bundles into, and then go ahead and screw those into the Pico breakout. And in some of these cases, this follows the sort of default wiring. For example, this one here is, I think that one right there. Oh, I did switch 2 of them. I think I got that wrong, actually. But ground, up, down, left, right are pretty much in a row in what's being expected inside of the GP2040 software. And then you can update that in software after the fact, or like I was saying before, whatever emulator you're playing with or software you're playing with will usually have a config where you can say, hey, I'm just going to show you what my up, down, my left, and my right are, my button A, B, X, Y, and so on. So that gives us this nice, pretty modular solution to wiring here. We get this all nice and wired up. I've got 4 buttons, joystick, and then start, select, and 2 of the shoulder buttons connected up right now. Here is my little, zoom out a bit so you can see this. Here is my little USB breakout. Runs right there. So I plug this in, and then I'll be able to set this down over here. I might screw it into where I might remove their board and just screw it in there. They have a little block of MDF that they've just screwed it directly to, so that works for me. There's even, I think, 1 or 2 LEDs on here that we could connect to. And then probably to use this as like a 2-player setup, I'll just build 2 of these. So if I'm playing on a computer, we're just going to have 2 USB plugged in, just like there's 2 controllers, or if you're doing it on a Switch or something like that, rather than trying to get all this wiring into a single Pico and do some sort of split 2-player thing. I think it might make more sense to do the 2 of them side by side. So that's the thinking behind that. And that's the easy solution for getting this thing wired up nice and easy. Last thing I think that remains is to figure out if there's something to do with this guy right here. So this is, I think, an entirely self-contained PS2 and USB trackball, based on it having its own little wiring bundle here that has a Y adapter built into this single wire that goes out to PS2 keyboard, mouse, and USB. I think that just shows up as USB mouse. So that one, not sure yet. I don't actually have a lot of trackball games I'm dying to play, although Centipede might be fun, or some, I don't know, is Tempest? No, that's a knob, who knows. But anyway, everything else here is pretty much just switches. One other thing I noted is that they, in their wiring, in many, if not all cases, their wires have little taps to add on other switches or to run the thing off to something else. So potentially that could be another way to wire it. But I think this one works well just because we have easy access to these JST XH connectors. They're all 5-pin. They're all pretty much the same thing. Even the LED here is just using a pair of them for that. I'm not sure what the other one goes to. I haven't traced it out yet. And I've left things, they've zip tied everything together nice and neat, and I've left it like that just so I don't end up with a new mess, but I may clip those if I need to search something down that's hard to find. So that's that. That is up and running right now. We can pop this bottom back on here. I probably don't even really need to screw that down. And you can see there's more of this this contact paper coming off in a couple places. In some places it looks pretty good. The top looks good still. I think that was a different sort of vinyl or plastic application there. I believe there are also modifications you can do for your joysticks if you want to turn them into like a gated 4-way. I think they're set up as 8-way right now, so you can press both buttons down when you're in the side. I think there's a modification you can do on these that'll turn them into a 4-way for some games where that matters. That's the guy right there. So I'm not saying you need to run out and get one of these. You may have weird old joysticks around. This will pretty much apply to any type of big arcade control panel. It could work if you have an arcade cabinet and you want to get the buttons up and running in some sort of a MAME emulation situation. This little Pico and the GP2040 software may be the answer for you. And then what I'll do is, if I can find there was a spare Pico here somewhere. Did I put it over there? I may have put it over there. I was going to plug in, rather than lug this thing over there, although I do have a long cable for it. Let's see where I put that. Where'd you go? There's a chance that I brought that into my other office. All right, well, we'll just run this extension then. I've got a really long USB cable on here as it is. Yeah, just checking the Discord over there. Yay, we have sound. Thank you, everyone who let me know about that. Yeah, racing games with the trackball. That'd be wild. And yeah, C. Grover. C. Grover says a pretty nice, a pretty non-destructive and reversible mod. And yeah, that's one of the nice things about this is being able to, you could really just plug those 8 cable JST plugs right back in. Put the old connector there, and it's like no one was ever there, right? So that's nice. I didn't want to have to go cutting stuff and making this a pain to get back to stock. Okay, so I'm going to plug the, if I can get my hub to agree, I'm going to plug in that Pico into this computer. And let's take a look at how this is set up. Okay, so that's up and running now. If we go back to my browser, what I'll do first actually is go to controller tester, gamepad tester here. Let's see if it's awake. I've got to actually plug it into the back of the joystick there. Okay, so now, whoops, now that should show up as a gamepad. So joystick, up, down, left, right. You can see that is showing up as axis 9. The other buttons I have should be these ABXY, which are usually somewhere in the button 0, 1, 2, 3 vicinity. That's my start button. That's one of my shoulder buttons there. Shoulder button, shoulder button. So that gives me an idea of what's working right now. Now, we have a couple of ways to get into configuration on this. So let me jump back here for a second. This is GP2040CE. That's what I'm running on here. And if you go to downloads, you can see these are all the boards you can put this on. I used, I think, a KB2040 for my Switch project. I don't think I did it on a Pico, but maybe I did. But here we have it on a Pico. There are a few other boards that are kind of purpose-built for this, for people who are making gaming joysticks. But these are all, we've got a SparkFun board on here, a Wave Share, a KB2040, and then a couple of Picos. I'm actually not sure what it can do with the Pico W. If that's a Bluetooth thing or a Wi-Fi thing, I'll have to look into that one. And then Web Configurator is super cool. So when you put this on, it's just a UF2 file. So you just put bootloader mode, drag it onto the drive that shows up, just as if you were putting CircuitPython on and the thing's up and running. Then you need to configure it. So one thing is plug in some wires for your switches. The other thing is you can start the board. If you see here, it says there's a built-in web-based configure application. You can start by holding S2. That's that start button is what I have that as, while you're plugging it in. So I'm going to come over here, unplug it from USB, hold that start button while I plug it in, and release. And now I can go to this web configurator here. Oh, that didn't go anywhere, did it? Let's try it again. Oh, I think that's not the button. Hold on. I think it's this one here. It's select and not start. All right. No? I had this working. So not you, I think it's you. Huh? Nothing? I'll give it a moment, but I may have the wrong. I also want to check that that button is working in the gamepad tester. Or is it this one? Could be that one. Okay, let's try that one. Dun, dun, dun. I don't know if yeah, I think I brought that other one elsewhere. Do I have a spare Pico in the house? All right, why won't this work? Can't think of a good reason. Let's try all the buttons again. Hold on. You're plugged into there. Not that. Okay, you know what? I'm gonna flip it open again and just make sure that I have something connected to that pin. So it's the GP2040 pin naming is calling it pin S2. My connection, I think, is to the GP17. This is the little chart here that's on their site for grabbing the GP2040 pin name and how it correlates to whichever microcontroller you're using. So they have one of those pinouts for all the different boards. Okay, so here, orange pin, that's still connected. Oh, hope I didn't bend that up too much. The only other thing I'm gonna maybe suspect is the does it not like having this enormous run of USB cable when it's trying to do this? I can try it on the little laptop that's sitting there too. No. All right, let's try it over there. I'll switch the camera up. And I'm going to plug this in with the shorter. This is a USB extender I've got here. Okay, so turn this so we can both see it. Oh, I went to the .info site. That is just documentation. Let's go. Web configurator. No, I have broken the web configurator. Okay, sorry, I won't be able to show you that today. Don't know what I did. It worked right before the show, but I have clearly done something bad. And yeah, I really think that's the button. That should be. Okay, so let's try one last thing, which is I'm going to pull my RP2040 out of here. Again, since it's on the screw terminal Pico bell. It's pretty easy to grab that. And I'll try plugging it in over here. So let's go to this view. All right. So first of all, I'll just plug it in here and see if we get it to show up in Gamepad Tester. And I'll need a jumper wire just to convince it. So let's see, it'll go from ground to one of these. Okay, so there it's showing up. And now I will power it down. I'm going to connect to GP17 while I power it back up. No, absolutely won't work. All right, I've broken something. Sorry about that. I put a new version of GP2040 on this right before the show. Might not have been a good idea. I don't know if it has some known issue that I'm running into here, but live and learn. Configuration in general is, if you look at the documentation here, it's all this stuff of picking your keyboard mapping, telling it if you're using LEDs for neopixels, adding macros, and so on. And that's what we can do in there to get it ready for whatever output we want for the game system we're using. All right, well, I think I'll cut my losses there. Sorry about that. I will be playing with this more and setting that up as a usable joystick, which, as a reminder, is our coupon code for today. So if you want to get 10% off in the store, maybe go pick up a one of these Pi cowbells, and we've got, I think the one with pre-soldered sockets here is not in stock right now. You can hit notify me if you want to know, but if you click actually on that one and go to without header, this one you can either solder your own header onto, or you can solder the RP2040 directly to that, which is also fine. That one will work. It's just a regular Pico. If you want to go completely solderless, wait for that socket headered version to come in, and then get a Pico H or a Pico WH, and those will just plug and play. And then I showed here, this is the JST XH. Now, actually, I will say I'm using this kit here, which you can kind of roll your own cables like I showed you. However, I'm going to get, I don't have any of these, but I'm going to get some of these 5-pin cable pairs just to see. Those should work pretty well, and that would be, again, a even simpler solution is just to plug into that second half there. You'll have a bunch of extra halves, but if you're just setting up one joystick, you might just need 3 of these and be done with it. So that'll be a nice, easy way to get those set up. And then play some arcade games. All right, that is going to do it for today. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop 1 hour later edition. And I think we have a deep dive with Scott coming up tomorrow, and then we'll be back next week with more shows. So please tune in and go to the Discord to find out more. Thanks everyone. See you next time. Bye-bye.
Thank you.